you 20 meters.
Well, good evening, everybody. Welcome to the July edition of the YCARS presentation meeting. I'm Hillary, AB1CD, YCARS' president. It's great to see everybody out here, everybody online. We have a fantastic presentation for everyone tonight. It's going to be on satellite communication, given by Tom, WA0POD. And is Andy? Andy? Yeah, Andy's here. There, sorry. Stand up, Andy. And Andy Kunick. What's his last name? AE8J is Andy. Couple of things of business. We do have a tight parking lot, so when everybody goes to leave, please be careful. Watch out for stop signs. And just take your time getting out, so watch for everybody else's car. If you haven't already seen Marty in person and gotten a blue ticket, please let him know and get a ticket before the end of the night. They're giving away a radio, a Yaesu FT for this thing. One lucky winner will walk away with this radio this evening. Tom, yes, and you have to be in the room. So if you have any questions, Tom will be happy to answer them. Is there going to be a pass later on?
Maybe if we have enough time. If
we have enough time for all the people in person, there should be or might be a pass later. So we'll try to get a live demonstration at the end. So without further ado, I'd like to pass this over to Tom, and we're excited for your presentation.
Thank you.
And put that wherever you need.
Thanks, Hillary. Just a reality check. Everybody can see our presentation at home and hear us fine. Yeah, I see heads nodding. Yeah, fingers up. Okay. And you're good in there. So, all right. Yeah, thanks, everybody. Let's see. All right. So we're going to talk about amateur satellites and working FM spacecraft. There's a lot of different elements to working satellites, and sometimes could be very complex. I kind of relate that it's like bouncing on one leg and rubbing your tummy and patting your head. And all those things have to go on when you're working a satellite pass. So it's sometimes pretty complex and not very easy, but we're going to try to give you enough information that gets you started and you can begin thinking about or working and listening to an FM satellite pass. So things that we're going to, before I start too, I'm Tom, W0POD, and Andy, AE8J, is my partner here with in amateur radio. We've done a lot together the last 4 years, and we met because of YCARS and through an introduction here. And we've had a lot of fun building a ton of 3D stuff and all sorts of satellite things. So Andy and I are partners in crime on all things related to satellites. So we're happy to help you in any way we can. I've been an AMSAT member for a long time, since the 80s, and as I got a little bit work tapered off a little bit when I lived in California, I got more interested in working the FM satellites. I was working the linear satellites earlier, but then I started with FM satellites, and all of this started just to balloon for me because I liked it a lot, and I liked the portable operations that we're going to talk a little bit about. So we're going to talk a little bit tonight about amateur radio history, a little bit about AMSAT. We're going to talk about CubeSat architecture. We're going to talk about CubeSats and FM. And then we're going to work through working the FM satellites. And of course, we've got a lot of material to cover here. So I'll get you out of here by midnight at least. The beginning of satellite age, certainly Sputnik, Russia launched on October 4th, 1957, Sputnik. I'm sure everybody who remembers all of that, all of you in the audience, yeah. We were there, and that created a huge amount of interest. I was a wannabe shortwave listener at the time, so I didn't have anything to hear it with, and you couldn't see it because it was so small. It was about the size of a basketball, is how big it was. And it was successful, of course, and the first recordings outside of Russia were made by RCA engineers and the Columbia University Amateur Radio Club here. And you already heard what it sounds like because we've been testing our audio, but this is, oh, go back. Come on. But the beeps also related to the temperature. So as the frequency went up, the temperature would deviate. So it was kind of labeled as scientific satellite. And so the United States entered the space age with Explorer 1. There was a lot of pressure. And actually, you all remember Werner von Braun, who was captured from Germany and came over to the U.S. He had a lot to do with this satellite when it was launched in 1958. So a personal experience, the first real satellite that I ever experienced, and maybe a lot of you did too, was Project Echo. It didn't have anything to do, we couldn't hear it, but you could see it. And I remember living in Iowa, we'd get the Omaha World Herald, and they published the times at night when you could see Echo go across the sky. And so my mom and dad, my brother, we were all out back of the house and looking for the satellite, Project Echo, and we saw it. And of course, it was tested as a microwave relay. So they were bouncing microwaves off that satellite and back down. And it was certainly my first experience in terms of a memorable experience that I could remember having something to do tangibly with satellites, and it was pretty exciting as a youngster. And then eventually I became a shortwave listener and onto all of this. So as the space age started, a lot of amateurs started to learn how to build these satellites, and West Coast amateurs from Project Oscar started to coordinate this effort in 1960. And it was, as you could see, Oscar is orbiting satellite carrying amateur radio. And that still exists today. A lot of our satellites are called AO. So it's AO 85, AO 91, Oscar, AMSAT Oscar, whatever. And the amateurs who built this worked at TRW, Thomson Rainbow Woodridge, which is now Northrop Grumman in Los Angeles. A little fact in that when I lived in Los Angeles, there was a ham fest in the parking lot of TRW every month. It was like a huge ham fest. It was every month in Los Angeles. So it was a lot of fun, and it was fun to go there. So after much work, the Air Force agreed to launch the amateur satellite with this Discover satellite from Vandenberg Air Force Base. And this is Lance Ginner, one of the builders. I actually met him a couple years ago in Washington, D.C. at an AMSAT symposium, and he was there with a model of Oscar 1. And so here he is in his shack, and check out all the Heathkit gear behind him. So he was certainly a builder, and the Oscar 1 satellite was weighed 10 pounds, and it transmitted Morse code, and all it said was hi on 144.983, and they built it for $68. Of course, who knows how much it costs military to send it up, but and so again, Oscar was launched on this rocket, Thor Agena. It was the first non-governmental satellite, the first launch of 2 satellites on one launcher, and it transmitted until the 3rd of January, 1962. So it was up there for quite a while, and or a month or so, 2 months, and running on batteries. 570 people heard it. It was 140 milliwatts, 2 meters, and said hi. Lasted there, he said, 22 days. And here they had a science experiment on here too, that the tone increased as the space temperature went up. And it re-entered on January 1962, January 31. And then decades later, we learned that there was a spy satellite on that, not on that ours, but on the companion satellite that was launched. And this actually starts an interesting transition in that with a lot of the amateur satellites launched going forward, and that we had the opportunity to be the secondary payload on many spacecraft. So here is the second model that when you build a satellite, you basically build a spacecraft to fly and you build a ground spare. So if something were to happen or the rocket were to blow up on the pad, you had another one that you could easily deploy and get that payload into space. And here you could see some of the internals of it, all staked boards, PC boards, hand wired and everything. So a little bit about the birth of AMSAT. Members were in the DC ham area, and they were affiliated with government agencies, with NASA. With NASA and other headquarters in the DC area, and they met in '68 and formed Project Oscar to revitalize amateur satellite program. So that was started in March of '69, and they're a 501c3, and it still continues today. And with a lot of connections to NASA, provides an opportunity for all of us to continue to launch satellites. Here's the first board of directors. So the amateur radio service then continued into June 1971 and the birth of the amateur satellite service. So they designated the following bands: the 21 megahertz, 28 megahertz, and 400 megahertz. And if any of you remember the early RS satellites, RS 12 and 13, you could hear those. You could transmit on 15 meters and get the downlink on 10 meters. So it was an HF satellite, and it was pretty cool. So again, birth of amateur satellite back then, 2019. It's the 50th anniversary. So moving forward in time, it was skipping over a lot of other satellites here. Wanted to just talk a little bit about, things were going well, and then we kind of ran into some problems. So you can think about Oscar 40 as a kind of beginning of these phase 3D projects that were very large, very aggressive, and very complex. So Oscar 40 was one of the more complex satellites built by radio amateurs. It had rocket motors on it. It was powered with hydrazine for positioning. It was going to be a high Earth orbit satellite, and we'll talk a little bit about orbits later. But it was in an elliptical orbit. So with an elliptical orbit, as you go out away from the Earth and then come back, it moves very slow when it's out and it's visible, and then it makes a real quick pass on the backside. And so that was always, the high pass was always oriented over North America. And so that's an elliptical satellite pass. So after launch, there were some failures. And then in 2004, they did a rocket burn, and it blew a big chunk out of the satellite. And that was a terrible failure. And it was very disruptive for the community. So you could see how big this thing is. There's a picture of a man right next to it. And you could see some of the other satellites here that are smaller. And here, an adjacent picture, I actually went down and got a chance to go into the clean room in the early 90s for this. And this is a big satellite. And it took a lot of money, a lot of energy to launch this. So a lot of people were behind it. A lot of people invested in it, including the ARRL. And so again, Oscar 40 Phase 3 was the most expensive and time-consuming project. AMSAT DL was the project leader. AMSAT North America members were viewed. They and the leadership for AMSAT North America were responsible for building it, and that impacted our relationship with AMSAT DL and other people. So again, different expectations, keeping the donors, members informed, huge loss of confidence with AMSAT's project management team, need to revamp how projects are managed, documented, lack of high Earth orbit satellites. The members at the time got frustrated, and we lost a lot of AMSAT members and during that period. So it caused AMSAT to start on new projects. AMSAT DL decided on Phase 3E Express and some other Phase 5 activities. AMSAT DL is actually responsible for QO100 that was funded by the people in Saudi Arabia and Abu Dhabi, which is their geostationary satellite. It is very, very successful. And that's, but they had a donor, one of the sheikhs there, funded that. So it was a huge deal. So AMSAT North America decides on Project Eagle, a HEO project, and Project Echo. And both projects were unaffordable due to launch costs. So at that time, AMSAT was really struggling. So again, from then to now, the development of spacecraft matured over 40 years. Size, weight, complexity, RF options, band power, power sources, meaning solar, international cooperation, was able to spread the workload across multiple continents. Most of the development work in supporting satellite systems is not RF. The things that you have to think about is that a satellite has thermal mass, it has physical mass, just like you're going to balance a tire, except you have to worry about where the heat is because you don't want to boil all the electronics and everything else like that. And you've got positioning to make sure the satellite is properly positioned over the U.S. when it flies over our country. Say again? Oh yeah. Yeah, they are all working on satellites, and yeah, that's right. Right, and there were the RS satellite series, the robot satellites, and they continued to build those, and a lot of that was their universities, and our universities were really pretty late to the party. Now with AMSAT and some of the things that the organization's doing, they're hosting payloads, and we'll talk a little bit about that. Amateur radio had benefited from special relationships with the NASA low-cost or free launches. Agency and aerospace companies were willing to take the risks, and so several firsts were accomplished in those early AMSAT days. So again, satellites have come in all types and shapes. It says size, mass, digital or analog, orbital parameters, frequency, and then as we talked about payload. So there's just a quick snapshot of all the different types. So now let's talk about CubeSats, which is where kind of our interest has been rekindled. And so we're looking at the first CubeSat built by AMSAT, RAD Sat FX AO91. Actually, that's not the first one, but it's the one that this picture is. So how big are they? We've got some 3D prints here that we could pass around. And actually, this is the size of the satellite. It's 10 centimeters by 10 centimeters, and it weighs 1 to 2 kilograms. And that's got everything on board. And you would pass that one around too. I'm sorry? Could you repeat what you were just saying? Oh, sure. Sure. The satellites that I'm just passing out is very similar to one. You could see it down here. It's a 3D printed satellite that I printed, and Andy printed one too. And these are 10 centimeters by 10 centimeters by 10 centimeters. So it's a cube, and it weighs in 1 kilogram weight size. And on board it has batteries, transmitter, receiver, all the hardware. So again, there we'll review it now on the screen. 10 by 10 or 4 inches by 4 inches by 4 inches, weighing 1 kilogram, which is about between 2 and 4 pounds. So the exciting thing is the university began launching CubeSats. So as a less expensive way to put satellites into orbit. They not necessarily did they have all the expertise to do this. So what AMSAT did was to lock on to the possibility of building a payload, an open slot in these satellites so that they could, universities could ride along with the amateurs. So they would get permission from NASA for the launch, and we would have the radio part of it, and then they would have their science experiment. So it was a great partnership. Some transmit only telemetry, while others carry transponders for voice and/or data communications. So again, as I said earlier, took advantage of large growing interest in CubeSats. AMSAT developed a family of CubeSats with ham radio transponders that were attractive for hosting experiments, and they partnered with the universities. So the universities, it's real easy for them to get these free grants from NASA. And then with these STEM payloads, they get this ELNA, Educational Launch and Nanosat program, where the university basically gets the permission for the satellite to be launched. AMSAT would build and integrate the satellite, and everybody wins. And so the telemetry would be transmitted in what they call, I don't know if I've got a slide on this, but it's digital audio under FM. So from 300 kilohertz down, they're transmitting digital data. And on the audio side, where we listen and talk on the satellites, that's been cut off, so you can't hear that. And then you can have a normal FM transmitter, very much like a PL tone. So it's subaudible tones, and they're very low data rates. Of course, they want higher data rates now too. So CubeSat difficulties and challenges as we continue to build these things. They required hardened parts. They were expensive. Customer off-the-shelf parts can be sensitive, like the stuff we buy for our ham radios. You can't necessarily take one type of integrated circuit and put it into space, and because of gamma rays and so on, it'll basically blow up the chips and make them non-functional. So, and then they just don't work. So you have to get the right parts. They did experiment with finding special parts that could be modified or properly protected on these satellite systems. So in vacuum, and everything you know about heat is wrong. That we only have conduction and radiation. There's no convection in space. And so a lot of the commercial satellites use things called heat pipes. So what they're trying to do is keep the core of the satellite at 72 degrees. And on one side, the side that faces the Earth, it's 300 degrees below 0 Celsius. And on the side that faces the sun, it's 300 degrees Celsius above 0 Celsius. So it's really hot or really cold. And you got to live in that middle part right here that you've got to do that thermal balance on the satellite. The power is very small. You don't have, on those satellites that we're passing around, the solar cells fit on those 4 surfaces around the satellite. So you don't have a lot of space to do that. So you're looking at them to charge the batteries. And sometimes on even the satellites that we have now, they don't want you working them at night. So you can work them during the day. Solar cells can charge, not at night, because that would essentially kill the battery or damage it. One of the other problems, I don't know if I've got it in here, is that we had some early problems with these satellites because a lot of the batteries that we were given were seconds from commercial environments. And about the time those satellites launched, the batteries had a very short life. So that was really a bad decision on behalf of our builders and designers, but they really didn't know. A lot of this is, you're building a lot of memory mass and memory muscle when you're building these satellites. So again, now we're CubeSat difficulties and challenges. They're popular because the universities love them. Even the military, they were building them for their military programs. The price goes up. AMSAT has no previous experience with these things when we started this. Tiny design, little power, 1 watt, and less tweaking for temperature and control. So here I am with an engineering unit at Dayton in 2014. And again, you know, you could see as you held that satellite, how small it really is. So Fox 1A AO85 was AMSAT's first CubeSat. And this was a revelation for AMSAT to go away from these larger, complex satellites that had so much exposure to be launching these smaller satellites that we could launch several of them and tolerate failures. So it costs about $100,000, $120,000 to build one of those satellites, the small ones. It costs about that much to launch it too, because you have to go through spacecraft testing, and we'll talk a little bit about that. So this was the smallest satellite built by AMSAT North America, as we've talked about. Fox 1's 4x4x4. Miniaturization level never attempted before by AMSAT. Coaxing the maximum power from the limited solar panel was a challenge. New heat challenges, as we talk about. You've got a lot of heat on one side, a lot of cold on the other side. And success gives the CubeSat design heritage the opportunity to really put AMSAT back in space. And now there's all sorts of agencies and people and organizations are building CubeSats. So again, what was inside? The mission was to engage our next generation. We wanted it to be simple with a 2-way FM transponder. So it was like a repeater in the sky. It wasn't linear. It was, you know, just like we worked the local repeaters around here. It was one person could use it at the time. There was a gyro experiment by Penn State on board. There was another experiment by Vanderbilt, and Virginia Tech had a camera on board. And again, our RF power was 800 milliwatts, but they cranked it back to 50% power after they launched it because they didn't want to drain the batteries and didn't want to risk blowing out the finals in the satellite. So they treated it very, very carefully. So it was planned for about a 470 kilometer height above the Earth, and by 780, which means that it was slightly elliptical with a 64-degree inclination that would allow it to go over the middle of the United States. The expected lifetime of these satellites would be 11 years. So they remain in orbit for 11 years. And now the orbital parameters for anything that you launch into orbit is governed by the United States by your mass. So if you launch a certain weight into space, based upon that weight, they'll tell you, you have to deorbit it in a certain amount of time. You have to have a deorbit plan. Additionally, now the industry, the CubeSat industry, if you will, is working on different technologies to have plasma jets or plasma impulse jets or rockets to force the satellite down so it could be re-entered on demand. There are also technologies where they've got a satellite called SailSat. And so the satellite deploys like a sail, and there really isn't any, you're in thermal vacuum, but it does slow the satellite down. And with that, it would lose altitude, lose elevation, and start to re-enter and then burn up in the atmosphere. So again, May 19th, it died after 4 years of operations, probably because of high temperatures and full sun orbit periods were overstressed the batteries and the construction parts on this. So here's how the antennas were basically laid out on Fox 1A or AO85. There's a 2-meter whip and a 70-centimeter whip. And what they did was they used, I think I talk about it, this nitrile wire that's wound around one side of that satellite, one face. And then it's terminated in a fishing line that's wrapped around a resistor. And they put power to the resistor burns the fishing line open, and the antenna flops out. So pretty cool, very simple, and it was very reliable. It worked. Now there's better systems now, but that's how they did it, in that those antennas would be wound around each side, and when they were unfurled, this nitrile wire maintains its memory. So as you saw in the models that we passed around, there's different layers in here. Now those are simplified, but the real satellites had all sorts of extra panels in there for solar management, power management, science, batteries in the middle of it. You want the batteries in the middle of the spacecraft, the internal housekeeping unit, a 70-centimeter receiver, and a 2-meter transmitter, and again, solar. One of the other issues is that when the satellite goes into eclipse, or on the dark side of the Earth, when it goes around in orbit, it does drop down to 300 degrees below zero. And when it does that, there are heaters wrapped around the batteries that keep the batteries warm. So when it comes back out, the batteries aren't fully depleted. Also, in testing the satellites, they have to go through thermal testing in ovens and vacuum chambers, and they have to be all wired up and operating functional, and they have to pass those tests. At the same time, they put them on these shake tables, and it simulates the vibration of the rocket being launched, and it has to survive that, so the wires and the parts don't come off the satellite and fall apart. So Fox 1 series would be mostly FM. They're easy to use, one user at a time. Communications exactly like an FM repeater, and it allows you to. The great thing about it is it allows you to use the satellites with the same kind of transceivers that we use in our radio. Say again, Hillary? Oh yeah, I'm sorry. So the again, the benefit of this is that everybody's got a FMHT and they got a mobile, and so that's the great thing about working satellites. We've got the hardware already, most of the hardware. So the power would be transmitted, like I said, 600 milliwatts, depending upon the voltage bus. The FM beacons are really running about 500 milliwatts. That's telemetry. AO73 had a high power beacon. AO73 was launched by AMSAT UK, and particularly as a science experiment for students in the United Kingdom. And it was a very successful satellite. They built and sold a special SDR and antenna for schools so they could monitor and track telemetry and follow the science on that. So that's a very exciting part of the hobby, is telemetry monitoring and following the telemetry. Some guys just, put up an SDR and listen to the satellites and log the telemetry and send it in. Both were easily heard with a rubber duck, and the telemetry is, AMSAT provides a free application where you can load it on your computer, hook the SDR up to it, and it'll decode all the telemetry into, so you can see the battery voltage and the attitude and the position of the satellite. So again, there's a lot of kind of details that are on the satellite with the telemetry. You can see the current, the min and the max, battery voltages, solar panel temperatures. As the satellite moves through the Earth, it does, most satellites do tumble. These satellites are not gyrostabilized. So typically on wherever our CubeSat is, if you got a hand me a CubeSat. I won't talk long. So also in another, I guess you could call it another power hog, besides the resistive heaters on the batteries, is that there's a coil inside, and it's like a pulsing coil. I mean, anybody like used to have a degausser for your color TV and that kind of thing. So they have basically a big electromagnet here on the spacecraft, and they could pulse it. They could send pulse to that, and that begins to twist the satellite in a certain position to keep it oriented as it goes around in orbital environment. As if you could imagine, this was a satellite. When it comes up over the horizon, it typically comes up with the antennas parallel to the Earth's surface. And if those satellite antennas are off, or these monopoles are not pointing in the right direction, you get what's called a fade. So a lot of times when you're working satellites, and you'll be going along fine, everything sounds great, and then all of a sudden it's quiet, and then it comes back up aloud. And so that's what happens when the satellite begins to tumble. And these newer satellites are going to be better about that as we go forward. But those are some of the early issues that we've had to work around. And so anyway, a lot of this information is good stuff to have, helps AMSAT design better satellites and understand the orbital mechanics related to this. Here's a picture of Jerry Buxton, who was the VP of AMSAT engineering during the AO85 acceptance. So they have to go through all of these tests, the shake and bake, they call it, the thermal vacuum, and when it passes, then you basically get that battery charged and put it in a case and carry it very carefully out to a facility for spacecraft integration. So now we're going to talk a little bit about launcher integration. And some of this is kind of like, we're going through driver's training, and we're talking about how the engine works and how the transmission works. So that's some of the background of what I'm going through here to give you an idea about how the device is made. CubeSats for NASA have been integrated by Cal Poly San Luis Obispo, and they've got the Naval Postgraduate School there and space stations, which give the military individuals opportunity to get exposure for preparing launcher integration. So here you can see, they call it a P-pod, and there are several CubeSats on the table, and then you can see the CubeSats inside the P-pod. So now the P-pod is really, how many of us had a Pez dispenser at home? Huh? You ever had a Pez dispenser? So the P-pod is exactly like a Pez dispenser. It's very simple. It's a housing that holds 3 CubeSats, 3 10 by 10 by 10 centimeter CubeSats. And in the bottom of it, if we can see it, down here probably, it's a spring. It almost looks like a bed spring. And when it's time to launch that group of satellites on the launcher, they just fire the door opens up, 3 of them spit out, and then they wait a little while, and then they do it again. So it's pretty exciting to see it. So this is what the P-pod looks like all closed up. And here you can look, this is for one launch. Look at all of those different satellites that are out there. So this is where some of this rideshare technology was developed. And then here are all the different satellites that you can see. You can see Fox 1, there's a Bison Sat. Some of these were failed satellites, but Fox 1 was on board, and it was in this P-pod. And here's the launch preparation team. So this is the payload that it looks like when they take it and they mount it on the satellite. And then they box it up and ship it off to the satellite for spacecraft for launch. So the thing to think about is that, where are we? Well, we're, as amateurs, and sadly, we're kind of steerage. And so we don't get a first-class berth. So there are people who are paying for the satellite, and those are the commercial operators. And they're of course, riding first class, and they're paying for more money. They are the first spacecraft launch when they launch a satellite. Of course, you can see the nacelles on there, the fairings come off, and then the rest of the spacecrafts are exposed. So then they typically launch the primary payload, because they tend to be geostationary satellites or higher Earth orbit satellites, where it has an upper stage. So in underneath the second stage is an adapter that hooks the two stages together. And that adapter is where these P-pods and these other secondary payloads are berthed, and that's where they get launched from, at a lower Earth orbit rather than a higher Earth orbit. The same but different. At this point, it pretty much, the launch looks like any other launch in different launch vehicles. You can see it all integrated in the next slide. And this is launched from Vandenberg. So this is the payload section being taken out to the launch site in Vandenberg. Again, then they're taking the individual P-pods and integrating those with the interface ring down here at the bottom. Hard to see that, but you could see the primary satellite and the fairing or nacelle on top of the spacecraft. And here you could see now the P-pod being mounted to this adapter ring between the first and second stage. And then, of course, the launch for AO91 and for Fox 1. But this is, I didn't have a picture of it or anything, but this is, so I think it was in late November 23rd, right around Thanksgiving, we were out shopping late night in Los Angeles, and I hard to hear, but that was Fox 1 safe mode. So in the safe mode, you can't transmit through it. And this is with my car. I'm just sitting out there in the parking lot, and I heard it. So I was very excited that, okay. So up next is AO92. This is an old one. We're going to just skip over that. We won't watch that. Then AO92 launched. Again, it was a successful launch, and maybe this will sound a little bit better. Fox 1 Delta. And that was like this radio sitting out in the backyard, so we could hear the satellite, and it was functional. So now Fox series, kind of moving on. As you can see, I've highlighted a lot of the spacecraft on the Fox 1 series. There were 5 satellites. We have 3 remaining, Fox 1B, AO91, AO92, and then AO109. All 3 of these in green are still functional. AO91 is really a pretty good FM satellite transponder. Fox 1C has been turned off. Of course, AO85 has re-entered and burned up. And then the last one, which is Fox 1E, AO109, is launched. And that is the first linear transponder that is flying right now. But again, it has some issues. So one of my favorite modes is one of the microsats called SO50, Saudi Sat. And that's where you get the Saudi Oscar 50. And it's one of my favorite ones. It's still up there, one of the strongest. This is bigger. So this is maybe about 24 by 24 inches. So it's got a lot more solar cells, got good batteries on it, runs more power.
Nothing heard. KG6FRY, W7JBI, Delta Mike 41. W7JBI, I believe, WA0POD, Delta Mike 04. The Hotel 2, Foxtrot. WA8, Delta POD, W7JBI, Delta Mike 41. Okay, Delta Mike 41, W7 Juliet Papa India, WA0 POD Papa Oscar Delta, Thank you for the contact. 7-3.
Well, that was a good pass. Nice and strong. I love them like that. So here we are. We talked about satellites. What do we need? Of course, we need an FM radio or an HT. It's like this one. We need some antennas. We need to understand the protocols. You need to have knowledge of the passes, and you got to have some prediction tools or tracking software to know when you're going to operate the satellites. So apart from when I first started, long time ago when I lived in Iowa, and I was actually listening to the Russian satellites with the Argonaut 70 whatever 5 QRP rig on 10 and 15 meters. So I got started, and you got a lot of fancy radios out there, but the one thing that I learned is that you really want to have a good radio, and I learned that the FT60 HTs, the Yaesu FT60s, were really pretty perfect for working satellites. They're rugged, they're sensitive. It's a super heterodyne FM receiver. It's not an SDR type receiver. 5 watts. And so I used an arrow antenna here, and I had a small battery here. And this is on a bush out back of my house in Pasadena. And I always put the radios and parts kept falling in the bush. So I put a towel over it, and it also kept the spiders from crawling out and biting them. But, and I did have, because I ran a little bit less power on the HT and the lower power range, but then I put a 25 watt FM amplifier on it, which got me up to maybe 10 watts. So I could hit some of the satellites because I didn't have as big an antenna or as much gain. And that really worked well. I did a lot of satellite work off that nice little bush out in the back of Pasadena. And it was fun.
Yeah.
Sure.
The antenna that you have there, you have to actually track the satellite with it.
Yeah, you do. You do. I've got one right here. This is in the stowed mode. So in order to, just so it's not as much work to take apart, I leave all the UHF elements on there. And then we built these 3D printed slot holders that hold all the 2-meter antennas. But when you're working the satellite, a lot of you seen me working before, but basically you have to follow the satellite by hand. That's what I was talking earlier about standing on one foot, chewing gum and patting your head and patting your tummy. It's you gotta move it, and you have to make a little bit of effort to orient the polarization as it goes across the sky there. But this antenna, for those of you who saw me working last time, it's pretty forgiving. And you can also, a lot of the folks take the antennas and they cut them in half. They cut them in half and say they use half of the elements and only 2 VHF elements. What that does, it gives you a broader beam width. And so it's not as critical when you're tracking the satellite. So if you've got an arrow antenna, you could use the back half of it, or just don't leave every boom together, but then take half the UHF elements off and take the first or top VHF element off, just so you've got the bottom 2, and that widens out your beam width, and it's a lot easier to track. It might be harder to get into the satellite, but you'll certainly hear them a lot easier. Good question. Okay, so the best satellites for initial contacts was that satellite that you just heard me working, was SO50. And so, there's the frequencies for it. It does have PL on it. The ISS is really popular, and it's a great satellite, if you will, to work. It uses a Kenwood radio. And the nice thing about the ISS is that it's lower in orbit. So it's about 200 and some miles above the Earth, whereas these other satellites, like a CubeSat or whatever, they're at like 500 miles, 400, 500 kilometers. So they're much further out, but having the ISS lower Earth orbit, and they're running much more power up there because they got that whole solar cell array, and they've got a lot of power to transmit with. And then the other satellite is AO91. Now we do have some new satellites that the Chinese launched, and they're called Tevel, and it's Tevel 2, 3, 4, 5, and 6. And you got to check for activity on these satellites, but they're new, they're FM, and they're pretty popular. And so it's a really great option, and they work great. So in order to find out which satellites are up or running, you can take a look at this list right here. These are all the active satellites today. Now you can look at, we got almost 30% more satellites with this latest batch of Chinese satellites for FM. And that's really exciting because it gives us a lot more opportunities to work the satellite. So there's more stuff flying. This page right here, amsat.org, two-way satellites, shows you in this kind of chiclet kind of display. You can see the blue chiclets lit up. Those are satellites that are active, and somebody's talked on them and worked them. And so that'll tell you that it's a good satellite to operate on. If you see empty space here, and it's red or it's yellow, it's probably not a good satellite to be talking on. So just don't even waste your time. But the ones that are blue, and here we are, I have to go back in and see this up real close, but AO91, the ISS, of course, Lilac Sat is good. The Trevels, like down here, I could see Trevel 3, Trevel 5, Trevel 4. So they're all good. And again, if you just look at these things before you go out and you try to operate satellites, you're going to see which satellites are functional and which ones are turned on or turned off. And a lot of these, they'll turn on the weekends. So like the Trevel satellites or some of the other satellites, in order to maintain the batteries, they'll leave a lot of these things off during the week, and then they'll turn them on like Friday, Saturday, Sunday. So that's a good time for everybody to get out and work the satellite. The other thing too is that find satellites or a space station or it's like SO50. And if you're maybe a night owl like me, a good thing is go out there at midnight. If there's a satellite pass at midnight or 1 in the morning, world's your oyster. Sometimes you won't have anybody to talk to, but you'll hear yourself if you have a full duplex radio. So that's a good time to get a lot of experimentation done. So satellite availability and tracking. So now there's a lot of low cost or no cost options for you. You could track satellites with your iPhone, your Android with the free AMSAT. I'll show you one of my favorites here. You could look online, Orbitron, Heavens Above, N2YO, AMSAT. They've all got orbital prediction software. So if you find a satellite that you want to operate, like SO50 or the ISS, which is probably the two that I would point you to because they're the strongest and they're going to be the easiest to work. Look for those satellites first and look when they're going to make a pass. And you just write down the time and look at what direction, if it's going north to south or east to west or whatever, just write it down and make a note of it and go out there and start tracking. And SatPC 32, that's $45 download. Nova for Windows is also available from AMSAT, and then Mac Doppler is one for Macs. Those are all good. But if you have an Android or you have an iPhone, there's lots of satellite trackers out there to buy. I personally, and I'm happy to show you after the presentation, but I use ProSat from a company called BossWorks. It's on the Apple Store. It's $9 a year. In my estimation, it's one of my best if you have an iPhone. You can go in there, identify the satellites that are good passes, meaning that a good pass is something that's overhead. You don't want to pick up a pass that's like 5 or 10 degree elevation because you're going to be shooting through the trees. So get one that's at least above 10 degrees and or even higher. 30 degrees is ideal and higher. But when you get a good pass with a good elevation, you can then take this and save it to your calendar, and it'll send you a reminder when to go out and work the satellites. So it can't get any easier than that. So it's good stuff. So I love ProSat. Again, it's $9, but if you're going to get into this, it's money well invested. FM radios, there's lots and lots of options. You just need an HT. Now, biophones work, ICOMs work, but I will say that if you're going to get serious about this, you really want to have a radio that has split memory. So you can have, on one memory, you can have receive, and on the other memory, you have transmit. And so that one is going to be UHF and the other is going to be VHF. And so that's a split memory that you want to be able to program. And so that's a feature in a radio that is more valuable than a radio that just won't do splits at all. And of course the Kenwood THD72A, which is now unobtainium, but this is a full duplex radio. So you can transmit and receive same time on this. This is a great radio. And yeah, we should, I've got some other stuff coming up here, but full duplex is really the best way, because with a single FM radio like an FT60, when you transmit, you can't hear yourself. So you don't know if you're into the satellite or not. So you're you have to do it on a little bit on blind faith. But when you're just using a simplex radio like that, you run the risk of interfering with everybody else on the satellite, because you can't hear yourself. So you don't know if you're into the satellite, or you don't know if it's working at all. So once you get some experience, then you'd have a pretty good idea that, yeah, I could track it and people can hear me and so on. But if you don't have any experience, having full duplex radio is really, really better. Now, we'll talk about that. You can do this with also mobile radios too. A lot of great mobile radios out there that are probably in a lot of your cars that are ready to go right now that you can use. So we'll come back to that. You can also use two radios. Again, buy two FT60s, one for receive, one for transmit. And so you got one you're listening to and one you're talking. And that works. And you can do the same thing with a biophone or whatever.
I know 10 years ago, you had a lot of good. You have to find yourself. That's what you're saying, 1, 2, 3, 4, and then you have to find yourself.
Yeah, well, that would be a linear environment. At FM, you're going to find yourself pretty easily. You're either going to be in or out. And then finding yourself would be, am I pointed in the right direction? That's kind of like all the things you need to do is, you need to watch the frequencies on your radio. One frequency, the VHF frequency, whether it be receive or transmit, has very little impact with Doppler. Right. And then you step through the UHF frequencies as you progress across the sky. And here's the next slide for programming FM radios. And so this is AO91, but they're all very much the same. We've got some handouts for you, but you just have to extrapolate this, because those handouts are dated, but it's the best that we've got on the website. So when you acquire the satellite, it's called AOS, acquisition of signal, and then you've got TCA, time of closest approach, and then you've got LOS, loss of signal. And so in your radio, I programmed this information. So I use RT systems on my radios, because it's a lot faster than doing it by hand on the front panel. And you type in this text over here, and there you can see I have 91A AOS. So AO91, acquisition of signal 1. And then it goes AO91, acquisition of signal 2. And then it's time of closest approach. So with those items, that kind of reminds you that you can do, okay, I'm starting out here, I acquire it. And then in about a couple of minutes, I'll change my frequency. And then when I'm time of closest approach, which is overhead or in mid path, I'll be at that number 3, and then I go to 4 and 5. So it's just real simple. 1, 2, 3, 4, 5. And that works. That works very, very well. It's very simple. And you have to be able to, on the transmit side here on AO91, you're going to be changing that. So you might be talking and, oh my God, I got a contact, and you sound great. And then you keep working and you forget that, oh, I got to change frequencies because now you can't hear yourself anymore. So you have to change that. On the receive, like 145.960, you're going to hear the whole satellite. So that's a great place to start. And we'll be talking about more of that later. But when you start listening to the satellite and learning how to track with the arrow antenna, you want to start by listening. And that is a big element of success, to be able to listen to the full pass as the satellite goes over. And again, the handouts are right here. So antennas, there are probably several major kinds of antennas. You've seen the stuff at Field Day that I have and Andy has, and they're more complex. They're bigger antennas, and they're on ASL and computer-controlled mounts. But the basic menu of things to choose is that you've got an arrow antenna, Yagi, as you see there on the screen, an elk antenna. Elk antennas work great, but they're a log periodic, and you have to twist them a lot because there's no vertical and horizontal polarization. And the axis on the satellite are vertically and horizontally polarized. So you got to do more work. So if I'm listening over here with an elk antenna, and so I transmit, have to do this. And then I twist it back to listen, and I got to transmit again. So those are a lot of pieces to do. A lot of guys love elk antennas. I'm just not a big fan of them because I found it to be even more difficult to use. And then you've got this Prime LA800 whip. This is an antenna. If I take it on cruises, and you can see this is a guy on a cruise, and you screw this onto your HT, but it's got a loading coil on it, and this is a pretty good antenna. And if you're traveling, you can take this with you. And you just have to remember that you don't talk with the antenna or the radio vertical, because the satellite's not vertical. You've got to actually, you're talking like this. You got to hold the radio so it's parallel to the satellites and make it pass. So a lot of times you're holding it down at like a 45-degree angle where it gives you the best signal. But this is a great antenna. If you're taking a cruise or going on a camping trip or something, you don't want to pack a whole lot of other stuff, you can make contacts with this on these FM satellites. Pretty good. Or at least listen and have fun. So minimal FM satellite stations. This is my buddy Patrick, WD90WK. He's on all the time. Lives in Phoenix. Probably not out very much lately. But he's very active. And here you can see he's got a wash-on Oshan UV9D, and he's working AO91 full duplex. And there's actually a brand new Oshan that's out that is a UV10 something that I saw on buy 2A radios for $200. That's full duplex. Now, I haven't heard anybody test it yet on satellites, but $200 for a full duplex radio, pretty good. And now it may not work all the satellites. It may not work like SO50, but most of the new satellites, which are UHF up and VHF down. The problem that we have within the ham community is on these kind of radios, when you transmit on VHF and you're trying to operate full duplex, the third harmonic is in the middle of the UHF band, and that desenses your radio. So you absolutely can use these Oshan radios for the satellites that have UHF transmit, and they work very well. So that's a great way to start. Just know that you're not going to have any luck the other way on the transmitters that have the VHF transmitter. And then he's got a small ground station. And ironically, and we kid Patrick a lot, but he does all of his work out in front of his house on a trash bin, a pink trash bin. And somebody made him a little pink trash bin that he carries with him that when he operates remotely. So he has a lot of fun there. And here you can see he's using a Yaesu FT817 and using an SDR Play as his receiver with a Windows tablet that allows him to see the SDR and his ELK antenna. And again, very successful. So you can be creative about all these different ways to operate. And then here's one on a really cheap. So this is a Baofeng with a homebrew Yagi antenna. And I've seen guys make this same thing as an arrow antenna, except they make it with welding rods and on a piece of wood, and it works. It works great. So you want to make yourself an antenna, listen, and knock yourself out. There's a lot of good stuff out there. And here's another one. This is the FM satellite station with 2 radios. So he's got a Baofeng, 2 Baofengs, and his log periodic and a duplexer that feeds the antenna. And so again, very simple. You can try these Baofengs and get in and get on the air pretty cheap. You don't have to spend a lot of money. There's a close-up of it. We'll talk a little bit about logging here in a couple slides later. So where are the satellites and what type of orbits? There's different orbits. There's low Earth orbit, LEO, geostationary orbits, GEO, high Earth orbits, HEO. And so you can see in this diagram, you've got this where these geosynchronous or geostationary satellites are, and they tend to be, put a big satellite up. Actually, EchoStar launched a satellite today, the largest payload, largest satellite ever put into orbit that we know of. Maybe the military's got something bigger, but it's a TV satellite, and EchoStar 24. And so those tend to be parked in around the Earth in 2-degree, 6-degree orbits for these high power satellites, but they tend to be at the south and about 20, 30 degrees elevation, 45 degrees elevation, and they look like they sit there, but they're really spinning with the Earth. So they stay with that location over the United States, and so every country has orbital slots assigned to them by the ITU. For these other satellites that are polar or inclined orbits, you could see that you've got high Earth orbits, and some of these they call, it's one a sun synchronous orbit developed by the Russians, but it's called Malonya, and it actually goes out there really far, and it comes back and moves very fast on the backside of the Earth, and actually those were developed for spy satellites, so that when they make the fast pass, it's low and fast as it goes across the backside of the Earth. It's the cameras are taking pictures, and then when it gets up the other side, then they slow the data rate down and send a very low data rate back to the Earth, where it's going to go up high and then come back. Then it comes back for another fast pass, and it's moving fast, so it's low and fast, hard to shoot down when it's moving at that high speed, or at least be interfered with. But high Earth orbits are very nice up to a point when you get 600-700 kilometers high. Those satellites, there's a satellite out there now, IO 118 and IO 117, green cube they call it. Those are digital satellites, and they will be in view for about an hour and a half at a time. And that's really great. You don't have to track them. You could have a fixed antenna and pretty much just point it at that portion of the sky. And that's the benefit of high Earth orbit satellites. But again, they're long way away, they're hard to hear, and they got to have a lot of power. So protocols, things you need to know to get your driver's license here. before you transmit, can you hear the satellite? When you start listening, you want to open the squelch all the way. And that's why in the recordings that you heard, the audio, the squelch is wide open because you don't want to squelch that signal down at all. Again, they have activity on them, daytime or evening, weekends. As I said earlier, late night's a great time to test. When I lived in California, I would be out there at 1 or 2 o'clock in the morning working satellites over the Pacific Ocean. And ironically, I never worked Hawaii, but there's never anybody off. So it was great for testing my antennas, testing my equipment. If you don't hear the satellite, don't transmit. There's probably there's one exception, and on FM satellites, don't call CQ. You don't call CQ on a repeater. If it were a linear satellite, you'd call CQ, but that's just one of the protocols. So one exception is SO50. The SO50 does have a timeout timer on it, and when you program your programming into your radio, and you want to, and it's supposed to be, the satellite's supposed to be up, and I'm not hearing anybody, you want to transmit with the 74.4 cycle tone, and that'll turn the satellite on. And then it's on for 10 minutes, and then you can work the satellite. And I've turned the satellite on many, many times because, again, if it's late at night, people are not, but usually 95% of the time, satellite's on when it comes up because it's making a pass across the United States, and somebody's turned it on before you got to them. Let's see, AO91 requires a PL tone, but these downlink services are shut off 60 seconds after the satellite doesn't hear any more tones. But if everybody's talking all the time, it's usually up all the time. Again, getting started, weak signal downlink. This work that we're doing with satellites is actually weak signal work. The satellites under 100 watts are hundreds, 400 or 500 kilometers away. And if I'm looking at the range data on my tracking programs, I start to hear the satellites at 1,000 miles. So I'm basically working DX when I start to hear that satellite at 1,000 miles away or 800 miles away. I'm not, when I see the satellite and I start tracking it and I see that it's 2,000 miles away or 1,500 miles away, I don't even try because it's not going to work. It's not strong enough. You don't have enough signal. So you got to get it at least what I think for acquisition of the satellite under 1,000 miles. Now, when I'm dealing with loss of signal, sometimes I can still hear it and work it at 1,300 miles. Now, why does that work? I don't know, but that's the way it is. So it's always harder to acquire than it is to lose it. Let's see. Question? Yeah, preamps are great. I've got preamps in all my radios. That helps a lot. Again, you've got you've only got so much gain, or like Arrow, they also make another antenna. It's called an Alaskan Arrow. That's bigger. Now that's like, I don't know, it's waving a big wand, and after a while your arm gets tired. Yeah, a tripod or something. Yeah, that works. That's a good question. So moving targets, these satellites are moving targets. So an average low Earth orbit satellite travels about 5 miles a second or 17,000 miles an hour. Again, your mileage may vary, but generally it's booking. And typical pass will last, if it's an overhead pass, it'll last 12 to 15 minutes. So you got 12 or 15 minutes to make the pass, listen, make a contact. And one of the things too is that you don't want to be a hog. You're not going to work everybody on the satellite. So don't do that. Take one and run. Get one contact and go, oh my God, I'm happy, and move on to the next one. So Just wait for the next one, next satellite pass, because there's a lot of people who are trying to work these things. And especially there's a lot of guys. Now, I haven't done it, but I intend to do it. But they're called rovers. And they're guys just like you that have all this great success doing parks on the air. So you go to a rare grid and you set up, and everybody wants to talk to that guy because he's the fox. He's the guy that you want to talk to. And so you want to be respectful of everybody trying to work a guy at a certain grid location. And then you can get all your grids and be a grid master. I am not. But it's a part of the hobby. Doppler effect, again, the satellites move fast. Its receive frequency moves up, down. The transmit frequency moves up. So again, that's that whole thing of what am I doing? Where am I pointing? And you have to get a rhythm to how that all works for you. And then dual band, most satellites receive and transmit on different bands. It's best practice to listen to the downlink, for your voice before you transmit if you've got full duplex. So all of these things, I'm going to go get a chart here. I'll be right back. I've got all this stuff over here. But, everybody has I'm sure all of you have cheat sheets or some way to remember this stuff because there's so much stuff to remember. So I made these are mine, and they're built for my TH-72, but it reminds me how to program my radio because I don't sometimes use it that much. And when I do, I want to be successful. So I made these larger sheets to help me program the radio, but then I'm going like, well, this is really too big to carry in a little bag. And so I made little ones. And so I just shrunk them down and printed them out in a color, and I laminated them, and they were great. And I can have knowledge of my radio reliability here when I bring all these things back home. I also have, I call them frequency flip charts for my other radios. So I've always got some sort of, I call them transponder reference materials so that I know what the heck I'm doing. Because again, you could be working any number of a dozen satellites and then like, what am I doing? Okay, here comes this one. Which one's up? And you need to have all this information. And you're welcome to take pictures or anything here. Again, operating techniques for the past. You've got to adjust the Doppler in 5 kilohertz steps. You saw the channel plan earlier. Check your AMSET satellite page. We saw that picture with the chiclets. Listen to who's talking. As you're listening, pick somebody out that's strong, get his call sign, write it down, and then go jump on him later. Call him by call. Don't call CQ. Share the pass. Let other guys finish. Don't be a hog. Use phonetics. Whiskey Alpha Zero, Papa Oscar Delta. Make it short to that station. And then give your name, call sign, and grid square. Everybody on the satellites likes to know that you're from, EM94, and I've got my grid. And then have a means to record contacts. I'll have another page about that here in a minute. And have patience. LEO satellites are busy. It's like field day every day on a satellite. And it's just rocking all the time. And that's what's great about it, is that you don't have to, satellites are wonderful because I don't care about propagation. And propagation is in all the time on the satellites. They're always up. They're always running. It's a lot of fun. So logging, that's another thing. If you have these memory lapses like me or Mitch McConnell, you need to know what the hell did I just say or who did I talk to? Yeah, all right. And so I like these. I've got some over here. But these are digital loggers. You can go buy them at Best Buy or at Staples or whatever. Best money you'll ever invest. $41. The Sonys are a little bit more expensive. They're not making the Sonys anymore. But basically, when I start a satellite pass, I may identify the satellite, the time, or I take note of what track I'm on. So it'll be track 91 or track 75. just random. And I write it down for an SO50 pass. And then when I get home, I decipher all of that and I figure out who I worked and what time I worked. And that works out great. So anyway, and I got a little splitter that I split my headset and my radio with, so that all of that stuff is wired and I don't have to worry about ambient noise around me and other things in cars and automotive noise or kid noise or anything else. And nice thing about it is that you can share the WAV files, just like you've heard tonight when I shared all these files. You heard the context. So if you get one that's really special, you can record it and share it with others. And again, there's a lot of operators. I would say the majority of operators are looking for confirmation for contacts using Logbook of the World or regular QSLs. Not many people use EQSL or any other method or say QRZ. It's that nobody does that. But Logbook of the World is probably the dominant contact logging technology. And they have grid masters. They've got, you can get worked on states, so all sorts of great awards that you could have. Getting started in AMSAT. If you're interested in this, I've got these flyers for you. As I said, they're a little dated, but you can, whatever you need, I can help you. Andy can help you, but you can download it here. But there's a printed copy you can take with you tonight. Let's see, what then we'll do that. There. Continue it. AMSAT is not going away. We don't have any more paid employees. She retired. And so now it's literally, AMSAT is a virtual organization. And all the engineering is done remotely by teams all around the US and the world. And there's a lot of great work going on about building our satellites. And there's a lot of work going on by, as you've seen, the French, the people in the United Kingdom, Germany, the Chinese are prolific at launching satellites. Their universities have got a satellite program, and they're knocking these things out all the time. The US has got some great satellite programs if you're interested in going to school, but Utah State, San Luis Obispo, they've all got these programs for CubeSats. And so it's a great resource. Consider being part of AMSAT. It's not cheap. Even ARRL is not going to be cheap here soon. So, but it's, if you like this stuff, it's the place to go. I think it's under $50, 47 bucks, something like that. And you get a bi-monthly email newsletter. I'm also on Twitter. I haven't given up to anything else, but there's a lot of guys on Twitter that talk about satellites and post about where they're going, what they're doing. And I've learned a huge amount, and I haven't done it. I need to do it, but I'm not a Facebook member, but there's a lot of good activity going on Facebook about satellites. And so that's a great resource there for social media. And kind of as we wind down, we talked about, and clearly you could tell I'm excited about satellites, and it's been a lot of fun. And it's for me, it's the major element of my amateur radio career. I'm a CW guy also, like Andy, but this satellite is really special. It's fun. We've used 3D printing. We've got computer programming. I mean, it touches all the buttons in terms of STEM, and it's really been a lot of fun. And one last slide here is that, last year, for those of you who haven't heard it or seen it, you can work the ISS repeater, but work in an astronaut, pretty good deal. And here's AstroKel.
Kilo 4, Juliet.
Gotta turn it down.
Charlie 4, 3, yeah. Kilo 4, Juliet, this is NA1SS, 1 Alpha, Delta X-ray. very good. Thanks for coming back to me. We're 3 Alpha, Georgia, Golf Alpha, and we really appreciate you being here in your off time. Really, really appreciate it.
Hey, it's a privilege to be up here, and it's a lot of fun to be able to contact with y'all.
Vulture's open all the time.
November.
NA1SS, WC4AR, 3ATN. WC4AR, this is NA1SS. This is Kjell Lindgren on the International Space Station. I am 1 Alpha Delta X-ray.
K4MSU.
Thank you for the contact. WC4AR, 3ATN, and have a great trip. WC4AR, thanks a lot, 73.
4 Lima X-ray.
Alpha.
NA1SS. Whiskey 4 Lima X-ray.
Whiskey 4 Lima X-ray, this is NA1SS. Welcome aboard the International Space Station.
Thank you. Please copy 7 Alpha, South Florida, 73.
Copy, South Florida. I'm 1 Alpha Delta X-ray.
November Alpha 1 Sierra Sierra. This is Whiskey 8 Delta Charlie.
Whiskey 8 Delta Charlie, this is November Alpha 1 Sierra Sierra.
QSL, we are 3 Alpha Michigan. Thank you.
I copy Michigan. Please copy 1 Alpha Delta X-ray, low Earth orbit.
QSL, thank you. 73.
73.
Kilo 4 Yankee, Zulu.
Kilo 4 Yankee Tango Zulu. This is NA1SS. I'm 1 Alpha Delta X-ray.
Thank you for the contact. 2 Alpha SC.
Copy 2 Alpha SC.
November 4 Echo Hotel. Kilo 4.
There we go. So that was fun. 4 in the morning. I was blown away that I was able to work it. So big deal. Join AMSAT, think about it. Thanks to Patrick Stoddard, my good friend in Phoenix, Andy, AEHA. Certainly got a lot of this information publicly and on the AMSAT Fox Series presentations. And of course, the National Reconnaissance Office has a lot of this data out there. Questions? Been a great audience. Any questions?
Is everything pretty much at FM now? Or is it FM?
What about it?
Is everything pretty much on FM?
No. If you go back and you look at all the information, there are a lot of linear satellites, and the linear satellites are a lot better to work, but you've got to have a little bit more hardware. You've got to have a UHF, the sideband radio to work that. And the nice thing about it is the transponders are 50, 60 kilohertz wide. So you can have, dozens of contacts going on, CW contacts, sideband contacts going on the linear sats. And you're not going to get this kind of repeater environment where you can't make a contact.
That's the way I would do it.
Yeah, you do have to. It's very much just like working field day. You search and pounce, but it's not as hard anymore with some of the radios like you see over here with spectrum analyzers in them. You see when they pop up, and you could zip over there and pick them up.
71A and 471A.
Yeah,
Oh, those robots are big.
yeah. So, please feel free to look at this stuff I've got over here. The box on the left is an FM transportable box that we used the other night out here. And that's a mobile rig. That's an FTM 400. And that's a full duplex radio. And if you've got, look at your radios. And if it says it'll do crossband repeat, you're home free. You got a full duplex radio. So crossband repeat radios are perfect for getting started instead of an HT, because you can run higher power. I don't run high power, but I'll run mid power with a smaller antenna, and you can make contacts all day long. And you just have to learn how to program your radio so that you've got channels on each side of the VFO. So I'm using one side of the FTM 400 is transmit, and the other side is receive. And you don't touch the other side, but you just click through the receive channels. And then the linear system that we're in the middle of building, and Andy, again, my partner, we've designed all these pieces and made them 3D printed to hold all these radios. So they fold away and flip up. But each of these is a full self-contained satellite system. The one on the right, which we haven't got on the air yet, but we will, but it's two IC705s, one for UHF and one for VHF. And the radios fold down in the box. There's a 6 amp hour battery in there, bi-lino battery. There are preamps built into the box and duplexers built into the box. So all I have to do is take that antenna and connect it to the ports on the side of the lid, and we're rocking. So feel free to look at that stuff. Any questions? Any
Hey,
more
Tom.
questions? Yes?
Hey, it's John. How you doing, buddy?
God is talking.
I've got a couple of old Kenwood THF6As that have a subband. Would those be good for satellite?
I have to look at them, but probably, I don't know what a
It's a Kenwood THF6A.
well, if you've got a pair of them, you can work full duplex regardless on FM.
Okay.
No, but I mean, you're two radios, so you just need a duplexer.
Okay. I was just
35
curious if you could do it with one since it had that wideband sub band on it.
Yeah, you could. I would run them full duplex, John.
Okay. All right. One other question. What are you using for a splitter for that recorder? Just curious. 'Cause then
recorder?
obviously you want, you obviously want to have your
found
mic
one
and your.
I found one on eBay, but you can wire it up. It's pure passive. It's I bought it. Bought it from Amazon. It's by Racing Radios, and it's a single input and has 3 outputs.
Okay, great. Thank you.
Yeah, and send me a note. I can send you the link if you need it. Now they make a lot of them that have 6 outputs, or I've got another one that has it's got a whole bunch of ports that you plug stuff into, but I kind of didn't like it. But just a box and everything's parallel, and most of this stuff is mono, by the way. So you have to put mono connectors on them to make them work.
Okay, fantastic. Well, thank you very much for doing the presentation. Great
Thank you.
presentation. Sorry I wasn't there tonight.
No, well, you can't win the radio show.
I know. I have enough radios, I think.
All right. Any other questions out there or in here?
I don't quite understand the difference between transponders and should we be running?
Sure. The trans.
Like the FP?
Yeah, I kind of relate it to it as a transponder, but because it is, one in, one out, except it's a repeater. FM is a repeater, but I still refer to it as a transponder because in many cases, there's a lot more stuff going on that satellite repeater that normally doesn't go on like, our local ham repeater. There's like data and other science type things that are going on in telemetry that you can't hear.
And communicating with one instead of linear, you have to have something like the Icon 9700 where it's got upper and lower sideband.
Yep. Or there's a lot of good radios out there. Yaesu's FT847. I've got one of those. ICOM makes a 910. They're older radios. They're very affordable and you can get them and they're good. And I as our amateur careers progress, you start out with something and then you sell it and buy something different. And I've got a pair of FT817s that are stacked, and that's a great. Again, they're not making them anymore, but they're great radios. So any UHF, VHF sideband, even if it's not linear or not full duplex, you can do it with 2 radios. And a lot of guys like Patrick, you saw him, you can do like a regular, if you've got a UHF, VHF sideband radio, and then you can use an SDR play, $100 SDR receiver, and use that. Again, there's some complexities there because you got a computer, more parts and pieces, but you can make it work. Good question. Anything else? Hillary, I think it's time for you to choose a winner. Or I can choose a winner if you hold up the bowl. Huh?
Like you.
Yeah, I'm not in there. You get it, let's shake it up. Make it super fair. I won't look, 'cause I don't know who I'm getting. Oh, this is it. Got one. I'm not looking.
The winner is Richie, W8RZS. Congrats. Okay, yeah, we can make that happen.
All right,
Is that all?
great. That's it. Thank you, everybody. There's
Well, thank you all for coming.
Refreshments.
Please eat some of the cookies and the cupcakes and the tea. And then stick around and ask some questions, but have a good night. Be safe.
thanks for coming. Yeah, please.